Hey folks, welcome back to CSE 1322. This is lecture number 7, and I am going to speak to you today about abstract classes. It's actually lecture number 8, that's what I was just realizing. This is for the week of September the 7th through the 13th, and this is the second part of Module 3, so we're doing slides parts 3 and 4 this week. You're actually going to get 3 videos this week. The first video is going to be this one, which is going to deal with abstract classes. The second video is going to deal with interfaces. And then the third video, I'm going to post a review video where I'm going to go through some of the material that we have looked at so far so that you can be prepared for the test, which is going to be coming up next week. So make sure that you are keeping up with stuff and that you're getting ready for that test on Monday and Tuesday. You'll have most likely 48 hours to complete that test. All right, so a couple of quick administrative things before I get started. In quiz number 1, there was a little bit of confusion about one of the questions, and let me just pull up that question real quick so that I can show you what I'm talking about. Okay, so having just pulled those up real quick, sorry it takes a minute to go find them. I wanted to talk about this particular question. This was from quiz 1, and it was question number 5. A number of you emailed me and let me know that you were misgraded on this question, and you're absolutely correct. Unfortunately, when we created the question in the system, we made a mistake and we selected the wrong answer, and unfortunately it graded everybody before we realized that it had the wrong answer. So deep apologies for that. A number of you emailed me and I told you that we would rectify it, which we now have. So let me just be clear about what the correct answer is so that everybody can be on the same page. So question 5 read, the state of an object refers to its attributes and not its behavior. And most of you selected true. I think 80-something% of the class selected true on that. And that is indeed correct. The state of an object is only referring to its attributes. It's dealing with what variables it has and what the current state of those variables are. That's the state of the object. The behaviors is not meaningful in the state of the object. The behaviors would be the methods, and they don't change just because you instantiated an object. So to be absolutely clear, question 5, the correct answer was true. If you answered true, it marked you as wrong originally. If you go back and you look at your grade now, what you will see is that you were given credit for either true or false. And the reason we did that was we didn't want to upset people who had previously looked at their grade and had realized that we had taken a point away. So we did not take points away from anybody. Effectively, this question, everybody got it correct regardless of what they answered. The vast majority of you answered it correctly, which was true. So the most important thing here is I want everybody to be clear that the state of an object does refer to its attributes. That is true, not its behaviors. That really is irrelevant. So that's question number 5 on quiz 1. And as I say, if you look at your grade, it should now reflect that that is correct. If you're having some weird problems or something looks wonky, by all means, let me know. All right, so the other one that recently happened, quiz number 2, completed this last weekend. And there's a very weird question on that quiz where we had somebody point out an issue. So in quiz 2, the question was, an array list can store objects and primitive data types at the same time. The wording of this question is a little bit strange, and that's why there's a problem with it. So to be clear, an array list exists in both Java and in C#. When we covered array lists, I mentioned that in Java, you can only store non-primitive types, i.e. object types, in an array list. So Java does not allow you to say an array list of integers directly. You have to say an array list of integer spelled out with a capital I, which turns out to be a wrapper class that's around the primitive type. So if we're just looking at this from the perspective of Java, then the answer in the system is correct. You cannot store primitive types in an array list in Java, and therefore that is false. If you, however, look at it from the perspective of a C# student, then this is where it gets a bit weird. So in C#, an array list by itself does not have a type declared when you create it. You do not say array list and then the angle brackets and then the name of the object. You simply say array list. And you cannot specify a type. There is another collection in C# called just a list, just LIST with a capital L, which works exactly the same as the Java array list, but it's different from array list in C#. So to be clear, in C# there are array lists and there are lists. Lists work the same way, and if that were the case, then the answer would be false. But since we specifically said array list, the truth is that in C#, the correct answer to this question is true. In C#, you can actually have many different types all mixed together inside of an array list. And very weirdly, that's actually caused some of you problems on labs that you've been doing this last week. I've had a number of folks come to office hours and ask questions in labs about they're trying to do the pull string method on the light bulbs, and they have them in an array list, and they're trying to say array list at position 7 pull string, and it's saying I don't have a pull string inside of that array list, even though you declared it to be of type bulb. And the reason for that is because you end up having to cast the return value because C# has no understanding of the object type of the data inside an array list. So in that case, you have to use a cast, which is something we're actually going to talk about next week. It's not something that we've really talked about up until now. If you do it with a list, you don't have this problem. So, to review, if you are looking at this from the perspective of Java, the correct answer to this question is false. If you are looking at this from the perspective of C#, the correct answer to this question as written is actually true. And as a result, regardless of which answer you chose, you got credit for it. And again, there's a note in your grade that shows that you got the credit either way. The vast majority of folks actually got this one correct, but there are definitely some folks in C# who were like, well, wait a minute, that doesn't make any sense. It is true in C#. So that's why we went ahead and gave credit to everybody. So hopefully that clarifies those two questions. We sincerely apologize. I mean, sometimes we forget that things are slightly different between C# and Java. We obviously try to make sure that we don't ask questions that are specific to one or the other, but it's going to happen every now and again, and we'll obviously rectify it for anybody who's affected by that. So hopefully your grades are reflective of all of that. Hopefully you're keeping up with everything and you're having a good time learning the material. Remember that if you stop watching videos at this point this week, you need to remember that there is a test coming up next week, and you'll need to keep an eye out for announcements on how exactly you're going to do that test, which those should be posted in the next day or two. Okay, so without further ado, I'm going to go through today's topics, which is related to, that is not the window, let me close that window, abstract classes. All right, so we have vaguely touched on this before, when we were talking about mammals, which was something that we had talked about before in a couple of the inheritance classes. So when we deal with inheritance, what's happening is we have a parent and then we have a child. And the child is inheriting a number of the attributes and a number of the methods from the parent. And we had said that it's not uncommon that in the parent, you might declare something that you know all the children will have to actually explain how to do, but you as a parent may not actually have any definition for that type or for that object or for that method. So what I mean here is, let's say that I have a parent and that parent is of type game. So every game will have a number of things that are in common. So it probably will have a current score, which is going to be some kind of private variable. It may have a high score because you're keeping track of a high score. And we know that there's going to be at least one method, which is start game. Every game would have to have a method called start game. But the details of how you start the game would vary from game to game. If it's a game of baseball, then that's one thing. If it's a game of tic-tac-toe, then that's going to be something quite different. So it's fair to say that we know that there is going to be a start game. And we might even want to mandate that if you're going to inherit from this game class, that you must specify how the game would start. From a polymorphism standpoint, we want to be sure that regardless of which game gets implemented off of here, we can always say game.start. And that magically knows what to do because it's been implemented in every single one of the child classes. So that's the idea of an abstract class. It is having a definition in the parent that says, I don't actually know all the details about how this is going to happen in all the children, but I am going to tell you that there will be a definition for this in each one of the children. And the way that this is done is very simply by putting the word abstract on front of a class name when you're defining the classes itself. All right, so why do you do this? And the answer is, well, the main advantage of doing inheritance is that you don't have to keep rewriting the code over and over again. For anything that's in common across all games, like how the high score is calculated would be the same in every game pretty much, right? People play the game. At the end of the game, they have a score. If that score is greater than the high score for that game, then we would replace the high score with this new score, and we would record the person's name and the time that it happened. That's the management of a high score, whether we're talking about tic-tac-toe or whether we're talking about Assassin's Creed. It's always pretty much the same thing. So this is a circumstance where I don't want to have to rewrite that in every single game I'm ever going to write. I'm going to write it once, I'm going to put it into my parent, and then I'm just going to leave it there and inherit it every single time that I write a new game. And probably more particular example would be the engine that's doing all of the graphics in the game. That probably doesn't change very much. How you translate a point across the screen is pretty much the same if it's a graphics game from one game to another. And so you probably wouldn't want to have to keep rewriting that over and over and over again, so you define that in the parent, and then as you write new games, you just keep inheriting all of these things that you've already done. And what you should always be thinking in your head when you're writing code is, how could this be reusable? How could somebody come along behind me, or how can I come along in 6 months and make another game and not have to rewrite all this junk again? Because it turns out you're very valuable. We don't want you redoing something that you've already done. That's a waste of everybody's time and money. So we want you to do it once, get it right, debug it, make sure that it's absolutely rock solid, and then forevermore just inherit from that and never have to rewrite that again. All right? So how do we go about doing this, and what are the rules? Well, the first rule is, as I mentioned, you simply put the word abstract in front of a class, and now bada boom, bada bing, it is an abstract class. There are a couple of rules once you do that. If you declare a class as being abstract, it is impossible to instantiate it. And that makes sense, because I haven't defined how game will play. Because game is just this abstract concept that explains that there will be games and they will have all these things, but I can't say play game, because that doesn't mean anything. I need to know what the game is, and I need to know what the rules are, and I need to know how it would work. So to be 100% clear, once you declare a class as abstract, it is impossible to instantiate it, meaning you cannot say game X equals new game. You will get a compile error. The way that you make it an abstract class is you simply say on any part of it, on any method, or in the header of the class, that it is abstract. Once at least one method is abstract, the class is abstract. So there you go. Like other classes, once you have declared as abstract, you just go ahead and define whatever fields you might have and whatever you implement whatever methods you might want to implement, and you can build all the constructors. So nothing about the class changed other than the fact that you declared that it's going to be an abstract class. And you declare the methods that you want to declare, and for the other ones you just put in a placeholder that says, yeah, we're going to have something about this later on. All right, and I'll show you in a couple of examples in a second here. All right, so again, the main reason that you do this is to reduce redundancy. You don't want to have to keep rewriting the same code over and over again. And the other reason for doing it is you would want to guarantee that all the people who are inheriting from you are doing the things that you know that they have to do. So if they're going to have an ability to, play the game, then they have to have a method called play game or start game or whatever it is that you've decided. And that makes it so that it's a lot easier to call classes of your children without having to know the internal details, because you're making guarantees that all of the children will have certain things. All right, the subclasses, when they're actually being written, these are the concrete classes that you're actually writing that have inherited from the abstract class. So they will absolutely be instantiated. So once I define my tic-tac-toe class, then yeah, it's absolutely the case that that will be instantiated and will be run and played and all the rest. The child, the concrete class, will have all of the methods implemented. They will actually have bodies of code, unlike the abstract class, which just says there will be a definition for play game. And in the actual child classes, you're never going to use the word abstract. So you're not going to say this is abstract for any reason. All right, so here's an example dealing with our mammal again. So we have a parent class called Mammal, and it seems to have a temperature, a weight, an IQ, and a fur color, which we've seen before, and all of those are marked as private variables. And then it has 3 methods, eat, drink, and move, which are all actually defined in Mammal. So up until this moment, everything about Mammal is a real class. There's nothing that would have made it an abstract class. The thing that makes it abstract is our next line in red, where we say abstract make sound. So what has happened here is there is no definition of how make sound works inside of Mammal. We are simply just saying there will be a method called make sound that has to be implemented in anybody who wants to be a child of this parent. So in our example down below, we have dogs, cats, and cows, and all three of them have to implement make sound if they want to inherit from Mammal. All right? So let's take a look at some of the actual details here. So in this example, if I say mammal M gets new mammal, I will get a compiler because that is not allowed. You cannot instantiate an abstract class. However, as we've seen in polymorphism, I am more than welcome to say mammal M equals new dog, mammal M equals new cat, or mammal M equals new cow once those classes have been defined. All right. So creating an object with subclasses that extends the abstract class. So we say dog D gets a new dog, and now we say D.eat. So let's go back and take a look at that UML diagram. So I created a new dog in that example, and for whatever reason, come on now. Oh, you're being weird again, aren't you? All right, when my pointer is not working today. So in the dog class in the bottom left here, you note that I never implemented a method called eat. But I inherited a method called eat from my parent, which was mammal. So I can absolutely say d.eat, even though there's no definition in there. That's not really an abstract, that's just inheritance. That's what we talked about 2 classes ago. When you instantiate a child that inherits, or when you define a class that inherits from another class, as soon as you instantiate that class into an object, the subclass, it immediately has access to all of the methods of the parent, as long as those methods are available through the modifiers. So hopefully that makes sense as to why you can say dog D gets new dog and then d.eat. Perfectly valid. All right, implementing polymorphism with the abstract classes. So note that when we said mammal M equals new mammal, we got a compiler. You're not allowed to instantiate mammal. But we did say that you're allowed to say mammal M equals new dog, mammal M equals new cat, mammal M equals new cow. And again, that's polymorphism because the 2 items on opposite sides of the equal sign are not the same. They are related. It is absolutely the case that a cat and a cow both inherit from mammal, but they are not the same class names. So the interesting thing is, once I've done that, I said mammal M equals new cat, I can now say m.makeSound. And it's interesting because up in our mammal, we never defined what make sound was going to do. We just said that there will be a make sound. So depending on whether I instantiated a new cat or a new cow, make sound will do one of 2 different things. I will either get a meow or I will get a moo, depending on which one I did. Unless it's a very confused cat, in which case he may say moo. I don't know. It happens. But anyway, the important part here is that when you instantiate a class, when you instantiate an object of a class that is inheriting from its parent, you may override any method. We have seen that before. If the method in the parent is marked as abstract, you must override it. So you must override make sound because it is listed as abstract in mammal. So hopefully that makes sense. So final summary here. You have concrete classes, which are the children, where you actually implemented things. You have abstract classes, which are the parents, where you declared that we're going to have this. And all of this is going to involve polymorphism one way or the other. So I thought I'd do just the example that I've been talking about here live. So I'm sitting here in REPL, and I've just made a new C# instance. And over to the right, I have run it once, and you can see that I get my default hello world. So what I'm going to do is, I'm going to look over here to remember what it is that I was previously writing. I'm going to do my game class. So I'm going to declare an abstract game class. So I'm literally just going to type abstract class game. And I put in my parentheses. All right, so what's my game going to have? So I already said that it's going to have a private int, which is high score. And maybe it has a private int, which is the current score. And I could even have a static variable. So I could have private static int games played. And again, static variables mean that they stick with the parent, they stick with the class. I'm sorry, let me say that again. Static variables stick with the class, not with the objects that are instantiated of that class. So games played is something that's going to stick with my game class. It's not going to be inherited. It's not going to be instantiated. All right. So now I'm going to come in and I'm going to declare an abstract method. So I'm going to say public abstract. I'm going to say it's a void, and it is going to be play game. All right. At this point, what I have declared is that I have a class called game. It's going to have 3 variables that are all listed as private, and it is going to have a method called playGame. If you wish to instantiate anything that is inherited from this, there will be a playGame. Note I did not put any code in here. I ended this statement with a semicolon. That's really weird. Normally when I declare a method, I would say public abstract void playGame, open curly brace, I would write some code, close curly brace. But I don't do that when I'm declaring it as abstract. I simply say there will be this. It's up to the children to figure out what that's going to be. All right, so let's make one of those children. So we're going to say class tic-tac-toe, and we're going to say that class inherits, as I try to find my colon, there it is, from game. All right, and remember, if you're in Java, then that colon there would be the word extends. And now I am going to go off and I'm going to start doing stuff. Just to show you where we are right now, if I were to hit run at this moment in time, I'm going to get a weird error. It says, error, tic-tac-toe does not implement abstract member game.playgame. So it realizes because I inherited from game, and because game very much mandates that there is going to be a play game, I have not implemented that, so there is a compiler error and it will not let me continue. And just to prove another point, I'm going to take this out for just a second, and I'm going to come down here and I'm going to run it. At this moment in time, everything should be good. There's no actual problem. I got my hello world. It complained a little bit about you've defined all these things but never used them, but those are all just warnings. Those are not actual problems. So I'm going to come down into my main and I'm going to say game x equals new game. And as you know, this should not work. Because I've declared game as being an abstract class, it's going to complain and say, no, you can't do that. You cannot create an instance of an abstract class or interface game. We'll talk about interfaces in the next video, but in this case, I declared it was abstract and therefore I'm not allowed to do that. And just one more point of clarification. The fact that I created the method playGame means that it is, because I declared the method as abstract, I have to declare the class as abstract because it is clearly an abstract class at this point. This is the problem of typing live. Once there is a single method inside of your class that is listed as abstract, the entire class must be listed as abstract. So again, this will not work because I am not allowed to instantiate a class. If I remove that, I get back to my hello world and the world is happy. All right, so I'm going to put back in my tic-tac-toe game, and I'm going to decide that I'm going to override playGame. So I'm going to pretend like I forgot to override it for just a moment, and I'm going to say public, I cannot type today. I apologize, everybody. Public void playGame. And I'm just simply going to say console.writeLine hi, which is obviously a terrible game. It's just printing out the word hi on the screen, but you get the point. I'm just trying to do an example here. So when I try to compile that, it says, no, tic-tac-toe playGame is hiding an inherited abstract member. So it's saying you went off and you declared something called playGame, and that's cool, I guess, but you're hiding the fact that there's already a playGame that you're supposed to be implementing. And since you didn't specify that this is an override, it's going to error and complain. If we were in Java, it wouldn't actually complain. It would have let me do this, and it would have overrided as long as the parameters matched, but you really should put the word override in there so that it has the opportunity, when I say it, I mean the compiler. Once you put the word override in there, the compiler knows, okay, you're clearly overriding the one from your parent, therefore the parameter list must match. The definition of that method must match the parent. So to fix this problem, I'm going to add in the word override, because that's how we do it in C#, and bada bing, the world should be good. I still have these warnings because I'm not actually using any of these variables yet, but at least it did compile. And now down here, I should be able to say tic-tac-toe x equals new tic-tac-toe. And that will happily compile and run. And I get hello world. And as a matter of fact, just to prove the point, I should be able to say x dot play game, and I should get the word hi in addition to the word hello world, which I do indeed. There it is. All right, and then the final thought is, just to prove that this also still works from a polymorphic standpoint, I'm going to say game instead of tic-tac-toe. So I'm using game x equals new tic-tac-toe, and that's also going to compile, and it's also going to do the same thing. And the difference here is my variable is of type game instead of my variable x being of type tic-tac-toe. But I'm still able to call play game on it either way, and it understands which one I mean because I specified new tic-tac-toe, it understands that if there's an override in tic-tac-toe, that's the one that's supposed to be firing. Okay, so I hope this example clarifies what an abstract class is. It's really not a difficult concept, and honestly, abstract is a great word for it because it really tells you what's happening. It's abstract. You can't make that. It's this definition. It's an abstract definition of what a class would be, and then when you inherit from it, you actually override the abstraction and you make it very concrete. All those words make sense in English, just like they make sense for C# and for Java. This example would have been, I believe, exactly identical if I had moved it over into Java. The only thing that would have been different is obviously the console write line would have been system.out, and the way that I specify that I'm inheriting from the parent would have been to say extends as opposed to the colon that I used here. All right, so I hope you guys understand abstract classes. There's going to be another video here in just a little bit right underneath this about interfaces, and then a review video that'll come in a day or two. I'll see you in the next video. You guys have a good evening or morning or whatever it is.